Let's go through the LeetCode 150 list. Starting with this one, merge sorted array. So you're given two arrays, nums1 and nums2. It says sorted in non-decreasing order. So that just means both arrays are sorted on their own. They want you to merge nums1 and nums2 into one single array that is sorted in the natural number order. So due to the nature of the input and output format here, it's a little different because nums1 comes with extra padding to accommodate for the merged array. Normally you create your own result variable and return that, but here they want you to use one of the inputs to store the final result. And we'll just see what that means here in the example one given. You have 1, 2, 3, 0, 0, 0 for nums1 as the first array. And then the second array you have 2, 5, 6, which will be merged into here, into nums1, and eliminating the zeros. So how would we accomplish this? Let's say you have one array and the other array, I believe, is 2, 5, 6. So let's forget about the zero padding for now, for the sake of just seeing the approach on how to solve this. So this is a tagged easy question. It's simple array traversal, and we're going to use 2 pointers. So one note here, most common case of 2 pointers is 2 pointers pointing at the same array. So like you have pointer here to 1 and pointer here to 0, and they do processing for whatever algorithm you're using. However, 2 pointer here means we're going to be having 1 pointer to one array, 1 pointer to the other. How do we solve this? If you just look at the numbers, how would you solve it in your head? You look, oh, 1's the smallest, so first it's going to be 1, and then I say there is a 2 and a 2, so that's going to be 2 2's. And then there's a 3, which is the next smallest, and then 5 and 6. Trackpad writing, it's terrible. How do we turn this into code? So we can, let's say I have P1 representing a pointer pointing at an index, and I have P2 so these pointers will be going through the arrays and picking out the smallest number. So here, let's say we started off at the first numbers. We see 1 is the smallest, so we pluck out 1 into our answer. And after that, we increment the pointer to the next spot. Then we compare these two numbers, 2 and 2. We see they're the same, so we can just pick any of them. So we say 2 and increment the pointer over, and Now we see it's 3 and 2. We see the 2 is smaller. So we put that in the result. And move the pointer forward. So now we have 3 and 5. The 3 is smaller. And we have no more numbers to process here. So whatever's left, we're just going to move the second pointer forward. So 5, move it forward, 6, and then we're done. There's nothing more. So that will be the final result. Simple array traversal. How would this look like in code? Let's go back here. I didn't mention how do we, because of the odd input-output format, we want to make a copy of nums1, but without the extra padding for the final result. So I'm using Java. That would look like this. Nums1 copy arrays copy of nums1, and the length will be m as it's supplied to us with the inputs. So now we initialize the pointers. Bar p1 equals 0, p2 equals 0. Now we have to iterate the arrays. So while p1 is less than m, which is the size of nums1, and p2 is smaller than the size of nums2. So now we want to pluck the numbers to compare them. So I will be doing it like this. Num1. So I want to make sure I'm within bounds, that there is a number I can copy, and if not, I'm gonna use a integer maximum constant. So it's like a dummy value that will never be in the result. So, and actually this should be an or. So, in that case, I will do the same check as the if statement for nums1. So if I'm within bounds, then I can take it from the copy array. Make sure you're using copy array and not the original input. And if that's false, I will use integer max value, which is the constant Java gives us. And I will do similar to num2. Nums2, p2. And here I don't need to do, we didn't copy nums2, so we just address it directly. Now we can do the number comparison. If num1 is less than or equal to num2, then we append it to the array. And we need an extra variable, which is to track the index of the number that we are inserting in the final result. So I will just call that I. Go to nums1 at index I and assign it to num1, since I know that is the smallest number. Otherwise, num2 is the smaller one, so that will be num2. So, and at the end of the loop body, I'm incrementing I by 1 to assign the next number in the next iteration. Of course, I have to increment p1 plus equals 1 here, since I just used it, and here p2. And I think that is all. Let's try it real quick. So it works on the initial input, and let's submit. Okay, yes, so that's 0 ms. I mean, the input is probably small. Yeah, we're dealing with 200 numbers at most. So what does the space and time complexity of this look like? So this copy can say it's O of m space. We're creating a new variable that grows with respect to the input, so it's going to be O of m space. I don't know what the copy of runtime is. I'm just going to guess is O of m time as well, linear copy. These are constants. I mean, they're not constants. They are mutable, but they are constant base since it's just one value. These are just single integers. They're not going to grow with the input. This loop here, we iterate through m and m, so it's O of m plus n time. And yeah, I think that's all. Inside the loop, we're doing array lookups, so that's constant time and assignments. So overall, O of m plus n time and O of m space.